In this video, we're going to be discussing what molar mass is and how we use it in calculations, particularly how we use it to convert between mass and moles of material. So let's start off with what molar mass is. Molar mass is the mass of 1 mole of a certain material. So this is something that we can do with elements or compounds. When we are trying to find the molar mass, it's actually fairly simple. We will use the periodic table for help with this. Let's take the example of an element, calcium. If I want to find the molar mass of calcium, all I have to do is to look at the periodic table, and I will find that its average atomic mass is about 40.08. Now we know that for average atomic mass, this is going to be in the units AMU or U. These are our atomic mass units. But the molar mass is equivalent when it's given in grams. So the way that we would normally report this molar mass is 40.08 grams per mole. This is a way of saying that if we have 1 mole of calcium, we would have 40.08 grams of that material. If we were doing the molar mass of a compound, we would do it very similarly. In the case of, say, calcium fluoride, this is CaF2, we again are going to look up the molar masses of the elements. Calcium is still going to be 40.08, and in this case fluorine is going to be about 19.00. To get the molar mass of this compound, we have to account for how many atoms of each element there are in a unit of the compound. So from the formula, we can see there's 1 calcium and 2 fluorines. That means we take 1 times the mass of the calcium, so we'll just leave that the same. But we also have to take 2 times the mass of fluorine because each unit of fluorine has, or each unit of calcium fluoride has 2 atoms of fluorine in it. Since the overall compound is made up of both of these sets combined, we will take them and add them together, and that will give us our molar mass again in grams per mole. And if we were to calculate this out, we would find that it comes out to 78.08 grams per mole. This would be the molar mass of calcium fluoride. We'll find the molar mass of any other compound in the same kind of way. First, by finding the molar masses of the individual elements from the periodic table, and then accounting for how many atoms there are of that element in the formula and adding them all together to get the total molar mass. Because we can see that the units here are a ratio of 2 individual units, grams per mole, we can use it as a conversion factor in dimensional analysis style problems. We could use this, for instance, to solve the question if we have 3.78 grams of calcium fluoride, and we want to know how many moles. We'll start this problem the same way that we start any other dimensional analysis problem, starting with the value that tells us how much we have. In this particular case, we have 30.78 grams, and so that will be our starting value, and as we generally do, we'll put that over 1 just to make it look like a fraction so it's easier to do the math with. From here, we know we want to convert to moles. In order to do so, we're going to have to calculate the molar mass, which was found above, and then use this as a conversion factor. We can see that the grams will need to cancel, so we'll need to have grams on the bottom of our conversion factor, and if we're trying to get to moles, that should end up on top. The molar mass was found to be 78.08 grams per mole. So in other words, 78.08 grams is equal to 1 mole. This means that the numbers we should plug in here are going to be 1 mole and 78.08 grams. With this setup, we should then be able to complete our calculation. And this calculation will yield that we end up with about 0.048411, etc. number of moles because our grams have canceled. And looking at our values, we have 3 significant figures in this value, 4 in the other, which means we should round to 3 significant figures, which will end up as 0.0484 moles. From this, we can see that 3.78 grams of calcium fluoride is about 0.0484 moles of the same compound. So as we can see, once we get this conversion factor, this molar mass, it's going to be used in the same kind of ways that we've used other dimensional analysis things. We're not really introducing too much new other than the individual conversion factor. The same kind of reasoning that we've done for our other conversion problems is going to apply. With this new tool in hand, you should be able to do conversions that involve changing moles to mass or mass to moles, as well as any other conversions that involve that as one step along the way.